Okay, our last lesson for this unit quadratics is over projectile motion, which is using quadratic functions in word problems.
Steph, no timeout with 6. At 5, Curry for the lead. Go!
Okay, notice the shape the basketball makes as he takes the shot.
Curry splits the defense behind the back. Fires a 3. Oh, he puts it in. What a spectacular move.
Notice the basketball created a parabola.
Hey, Stephen Curry knocks down the 3. The Warriors. Now here is Curry. The step around move to Livingston. No look, flip back. Oh
my! A projectile is an object that rises and falls under the influence of gravity. So in our example here and in the video, it was the basketball. So the basketball is the object. So this is the projectile. Projectile motion, however, is the height of that object as a function of time. So let's notice the axis. The x-axis represents time, and the y-axis represents height, either in feet or in meters. So you notice our basketball started at 6 feet. It reached a maximum height at 12, and then we can tell how long it takes to land. We're going to be using the y-intercept, the vertex, and the roots to give us important information of our situations. Let's first talk about the y-intercept. Of course, the y-intercept is always the point that crosses the y-axis. In this case, remember, y-axis represents height, again, either in feet or meters. So we can see here that our basketball was not launched from the ground, but it was launched 6 feet in the air. So our y-intercept in this case would be 0, 6. Another important ordered pair of our projectile is the vertex. Remember, each ordered pair gives us 2 pieces of information. And in all of our cases, x is always going to represent seconds and y is always going to represent height, feet or meters. So our vertex, this is a maximum point because all of these parabolas are going to be turning downward, if you've not noticed. So our vertex tells us that our basketball reaches a height of 12 feet. That would be your y value. And it takes about almost 2 seconds to reach that height of 12 feet. Now let's talk about our roots. We have 2 roots. However, sometimes one root is irrelevant. Let's recall that the x-axis represents seconds. Here at the origin represents 0 seconds. Anything to the left of 0 is going to be negative, and there's no such thing as negative time for us. So this root is irrelevant. So whenever your object is not launched from the ground, you will have a root that's negative, and you will not need it to answer any questions. However, we will always have one positive root because the object will always land. So this root here is about 3.5. So what does that mean? It means in 3.5 seconds, the height of our object is 0. It has landed on the ground. But sometimes our objects will be launched from the ground and we will have a root of 0, which will always also be the y-intercept. And again, we'll have an additional positive root. Now, if you need to pause the video and write down the projectile motion formulas, and here I've indicated what they mean. So your y-intercept is the initial height of the object. Your vertex, the x-coordinate tells you the maximum time that it takes for that object to reach its highest point. And then the y value is the actual height. Just always remember, x represents seconds, y represents height, either in feet or meters. So remember, negative b over 2a, that gives you your x, also your axis of symmetry. Then you plug that value into the function, and it will give you your y part. Your roots, unfortunately, we're going to have a lot of irrational values when we're getting seconds. Okay, so remember, roots is seconds because those represent our x values, our x-intercepts. And so if you get a negative root, that means our object did not start on the ground, and we have a negative root, which is irrelevant. So you're going to definitely make sure you have your calculator. And however, there are occasions when our quadratics will factor nicely and our roots are integers, but most of the time we'll be using the quadratic formula. Okay, there are 3 different projectile motions. We have one where an object is just dropped and it is not thrown. It's just like dropped off a roof, off a cliff in this case. We have an object that goes straight up and straight down. And yes, some time does go by, just even for a split second. So it does kind of create a parabola. And then you have your normal where you've launched it. And it creates a little bit wider parabola because more time has gone by before it falls to the ground. Here are a few factors that influence the height of the object. So the height from which the objects are dropped or thrown, so where it originally starts, whether it's upward or downward, whether you're throwing it up or you're just dropping it, and then the pull of gravity. Now, you can write this down in your notes if you want to, but in just a few slides, I'm going to be filling in what this A is. So this is just the general formula, and the A represents our acceleration due to gravity, which is just acceleration is kind of like momentum, just speeding up. I should say that's our velocity. Velocity is our momentum, it's speeding up. So we will have acceleration due to gravity. And so we're going to use the gravity formula. And then we have velocity. And then we have our initial height. So you can look at this as if normally we would have f of x, and then we'd have an x here and x here. But because we're talking about height and time, we're just going to use h of t. But if you feel more comfortable using f of x, that's totally fine. Okay. Since acceleration due to gravity is approximately 32 feet per second squared, or 9.8 meters per second squared on Earth, you probably have learned that in your science course this year, our A value will either be 16, and it's negative because remember something's going up, but then it's coming down, so it's making that downward parabola, or negative 4.9 if we're talking about meters. So just keep in mind, we're just taking half of the 32 and half of the 9.8. We won't go into great detail. You can read the note down here. But just remember, your A value is either going to be negative 16 when we're talking about projectile motions, or negative 4.9. And I will say, just remember, if your word problem talks about feet, you're going to use negative 16. If it talks about meters, you're going to use negative 4.9. And this will always be your A values for projectile motion. So this is when we have objects that go up and come down. And so if you're working in feet, this is going to be your formula. If you're working in meters, this is going to be your formula. Again, this middle term, your B term, is your velocity, your momentum, and your C term, like always, is your y-intercept, where the object starts. So let's write this down for sure. It's the same concept. However, we will not have a velocity because nothing is being launched or thrown. So this is for objects that are dropped. So you can see there's no middle term. So ultimately, this is going to be your formula. Okay, again, you will not have a velocity when things are dropped. If you're working in feet, again, negative 16. If you're working in meters, negative 4.9. Okay, we're going to stop here and pause. And the second part of my video is just going to be practicing problems.